Okay, so here's the one I would like to look at first today. You guys are all very, very adept at solving this equation, x squared plus 4x minus 12 equals 0. I'm using this webcam. The view right now is fine. I hope it stays fine. If I have to start moving it, I will. I know that you guys could solve this in a whole bunch of different ways. I know you could factor it. I know you could complete the square. And you could also use the quadratic formula. I've chosen to factor it. And so it clearly factors into x plus 6 and x minus 2 equals 0. And then you know to set each one of those equal to 0. And of course, you get two solutions. X equals negative 6 and x equals positive 2. So that's no-brainer kind of stuff. That's review. That's easy for you guys. But what if I take the exact same equation, x squared plus 4x minus 12, and instead of setting it equal to 0, I set it equal to y. So I have the exact same equation. I had a 0 up top and changed it to a y down here. Let's think about what that is saying. It's basically saying for x squared plus 4x minus 12 to equal y and to also equal 0, y has to equal 0. That's really what I'm saying here. And so think to yourselves, in a graph, where does y equal 0? On a coordinate plane, where does y equal 0? And I hope that you think to yourself, y equals 0 on the x-axis. So the x-intercepts of a graph would be where y equals 0. Well, if you were to graph this equation right here, either on your TI Inspire or by hand, you would get the following picture. Now, wait a minute. Before we talk about the picture, how would you graph this sucker by hand if you didn't know how to do it? If I just said graph y equals x squared plus 4x minus 12. I hope what you would say is anytime I ask you to graph something and you don't know how to do it, start picking numbers for x, plugging them in, and figuring out what it makes y. And if you do it for enough points and connect them, you get yourself a graph. Now, that's a pretty inefficient way of graphing things, and so we'd like to learn a better way of graphing these, which of course we will. For today, however, I would like our calculators to do it for us. Now, I'm not going to bring my calculator up on the screen, but I'm going to draw a quick sketch of what this equation looks like. It's going to be a little sloppy, but I'm going to draw it anyway. You may be familiar with the concept that quadratics, when graphed, look like a parabola. I hope you know that. And there's some interesting features about this graph, and I didn't label my axes at all because I wanted to wait a minute until I explained this to you. But the interesting features are this. I hope you recognize that this point and this point are the x-intercepts, and I hope you can predict that they are going to be located at 2, 0, because x equals 2 was one of the solutions, and negative 6, 0, because negative 6 was one of the solutions. So I hope you recognize that's how the graph would look. Now, this parabola happens to be a right side up parabola. We view ones that are going in an upward direction as right side up, and it's right side up because the leading coefficient is positive. This coefficient right here, this 1, is positive. Okay, well, what other interesting features do we have about this graph? Let's go down here. Important points I wrote. So important point number 1, x-intercepts. Got them. Check. Important point number 2, I hope when you look at that graph, you say to yourself, golly gee, I wonder where the bottom is. And that bottom, of course, has a very specific name, and I think you probably know it. It's called the vertex. And so I'm going to give you a couple ways of finding that vertex, and I hope one of them makes complete logical sense. Complete logical sense. So here's the story. If you look at this point, does it make sense that the x-coordinate of this point has to be exactly midway between the two intercepts? I hope it looks like this distance and this distance are the same. And so the vertex has to be midway between negative 6 and 2. Well, how do you find the midway point between two spots? You add them together and take their average. So negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. That has to be my x-coordinate. And so let's think about this. Negative 2 is 4 away from negative 6, and it's also 4 away from positive 2. So it makes total sense. So that's the x-coordinate. Y-coordinate. Well, it's not 0. I don't think it has anything to do with these zeros. But the y-coordinate can be found very easily by taking negative 2 and plugging it into the equation in place of x. And so let's do some arithmetic. Negative 2 squared is 4. 4 times negative 2 is negative 8. So I have 4 minus 8, that's negative 4, minus another 12 gives me negative 16. So there, my friends, is the vertex. Hey, look, negative 2, comma, negative 16. Okay, for today, there's one other important point that I'm interested in. I think you can probably guess it by looking. We already found the x-intercepts. So how about the y-intercept? And so in this particular graph, y-intercept is right in there. It's going to be kind of hard for me just to eyeball it and figure it out. And so let's think, what makes something a y-intercept is that x equals 0, right? You're on the y-axis, so x is 0. So go up to your equation, plug in 0, you get 0 plus 0 minus 12. Well, that is negative 12. So, ladies and gentlemen, the y-intercept is 0, comma, negative 12. Okay, and so this is how a quadratic relates, the graph relates to the equation itself. I've got a second one I want to look at. Just quickly. X squared plus 8x plus 12 equals y. I didn't even bother putting equals 0 this time because we're just going to think about the graph. We're going to think about how would this sucker look. And so if I want to know how it would look, yeah, I can think about solving it. So here, let's go ahead and solve the associated equation equal to 0. So you would factor it. So this one happens to factor nicely. And I think you get negative 6 and you get negative 2. Whoopsie, I'm off the screen. There. I know it's a little blurry now and then. This is a cheap webcam. We're doing the best we can. Okay, so important points. I think we already have 2 of them. We have the x-intercepts. And they are negative 6 and negative 2. So negative 6, comma 0 and negative 2, comma 0. Those are my x-intercepts. Now think what we just did in the last problem to find the vertex. We said the vertex has to be midway between those two guys. Well, I'm going to do that in my head. Midway between negative 6 and negative 2 is gosh darn negative 4. And then all we need to do is plug in negative 4 in place of x. And you can write this out. I'm going to do it in my head because I'm trying to save some time. Negative 4 squared, that's 16. That's negative 32. So I have 16 minus 32, that's negative 16, plus 12 happens to be negative 4. You may need to show your work there, but there's my vertex, negative 4, comma, negative 4. Lastly, if I wanted to find the y-intercept, which isn't as important to us today, but if I wanted to, it's just where x equals 0. So 0 plus 0 plus 12 looks to me like it's 12. Easy enough? Okay, so those should seem pretty basic. The last one I want to talk about is this. Now this one, let me change this camera just a wee bit. X squared plus 6x minus 3. You might notice right off the bat, that guy doesn't factor. Now we can still obviously solve the associated equation. We can certainly solve that. We have tools. We have completing the square. We have the quadratic formula. We've got tools. We know how to solve that. But it doesn't factor, so it's going to be a little bit different than the last one. I'm gonna complete the square just because I think you guys don't use that enough, and so I just feel like using it. So I move the negative 3 over. I'm gonna put whatever number there I'd like. So half of 6 is 3. 3 squared is 9. I'm gonna put a 9 right there, which means put a 9 right there. This left-hand side is going to factor. I'm going to take the square root of both sides. I'm going to simplify it as I go, because root 12 is 2 root 3. And I'm going to subtract 3 from both sides. And I'm going to get my solutions. Now, Here's the interesting part. Can we answer these three questions that I have on the piece of paper that's blurry intermittently? X-intercepts, oh boy. Well, the x-intercepts are the answers, right? So for this one, it was -6 and -2. Well, for this one of my answers is -3 plus 2√3, comma 0. And my other one is -3 minus 2√3, comma 0. Those are points. They're sloppy, messy points, but they're definitely points. Now here's what's going to be awkward. The vertex we said for the last couple problems was midway between those two spots. Well, midway between these is icky. It's icky to think about. And so sometimes that little trick, that little method, isn't your most efficient way. And so I'm going to give you a different way of finding the vertex that always works as long as we have things in standard form. So if we're in standard form, here's how we're going to find the vertex. The x-coordinate, the first coordinate, is part of the quadratic formula. It is the opposite of b, just like the quadratic formula starts, and then skip the whole rest over to a. So it's the first part of the quadratic formula and the last part of the quadratic formula. Well, in this problem, b is 6, so the opposite of b is -6. A is 1, so 2 times a is 2. So I have -6 divided by 2. Well, that's -3. Y coordinate, very simple. Just plug in x in the equation and solve for y. So -3 going in. -3 squared is 9. Minus 18 is -9. Minus 3 is -12. All right, so there's your vertex. Turns out you could have done that one the same way we did the first two if you were thinking closely enough, but a lot of times these 2 points aren't as easy to find the average of as this one could have been. Okay, finally, y-intercept. Y-intercept is where x equals 0, so 0 plus 0 minus 3. There you go. Okay, so this is a start. This is what I want to start with today. This is relating the graphs of quadratics to the equations we've been solving, if they're in standard form. We're gonna have more after this, but this is a start. So I'm gonna wrap it up. We're gonna stop. Please do the page I'm attaching for an assignment, and I will talk to you guys later on.